Well, in that last example, I kind of used the idea of saying that we could use the mass of the board at its center of mass. Now, how did I do that? Well, if we have an extended object here, and I want to find the center of mass of this object, you have different amount of mass at different distances. So when I did the sum, when I did the sum of the m sub I x sub I in the numerator up here, I'm going to have to take a limit as the m's get very small. So these become, so I'm going to take the limit as the m sub i's get very, very small. And so essentially, I'm doing an integral right here. Okay, so I'm doing an integral of x dm. Okay. Well, that would mean that if it's a uniform distribution, then that's going to be right in the middle right here somewhere, and so it's going to be right in the middle, and because you're going to have equal on either side. Now, if it's like odd shape like that, then it's going to be more to one side because you had more of the m on one side than the other. Remember, we're finding area under the curve. So you'd find the spot where this area balances the other area, and that's where it would match. So that would, what does that mean for us? It means that the xcm is going to be the integral of the x dm divided by the total mass, which is the integral dm. Okay, so there we have it. Now, the question is, if you have an object in 3 dimensions, what do you do? So you have an object in 3 dimensions. Well, what's going to happen is the xcm is going to be the integral of the x dm divided by the total mass. The ycm is going to be the integral y dm divided by the total mass, integral dm, and the z center of mass is going to be integral z dm divided by integral dm. The only hard part is figuring out how to do the dm integral, because dm could be in 3 dimensions. It is possible that dm is some rho dx, dy, dz. So you may have a complicated sort of thing here, but in essence, this is the basics of how you would figure this. So that's the integral form of the masses, or center mass.